Hey guys, this is just a side-by-side comparison of the two different forms of the quadratic function. And you can organize your information so that you can see it side by side. And then when you get one form or another, it may be helpful to you to remember the key features that you'll find. So looking at the two different forms themselves, the vertex form, you're going to have y or f of x, they both mean the output, equals a times the quantity x minus h, so we're always subtracting the h value, close your parentheses and square what you get when you do the subtraction, plus k. In standard form, it's y equals ax squared plus bx plus c. So when you identify your key information, here we're going to identify our A, our H, and our K and use that to find our key features. And here you're going to identify your A, your B, and your C. You notice that both sides we look for an axis of symmetry, we look for a vertex, we find other information, and we have our graphs. So let's take a look at just the vertex form. We'll focus on this for a moment. In the vertex form, we can recognize our axis of symmetry, which remember is x equals a number because it's the equation of a vertical line. It's right from the equation. We take the h value. Remember, the h is being subtracted, so it always looks like the opposite sign. To find our vertex, again, we go right to the equation that we have. We pull the h value and the k value, and that's it. You're done. That's your vertex. No work required. So when you go to graph your vertex form, you're going to draw your axis of symmetry and plot your vertex on it. Decide whether it opens up or down. That comes from your a value. If your a is positive, it opens upwards. If it's negative, it opens downward. And then we sketch our graph. So you can see I drew the axis of symmetry. I plotted my vertex. I know it opens downward, but the only way we can find the rest of the points is to make a table of values. And what we do is we pick two numbers, two x values, that are on the same side of the axis of symmetry as your y-axis. Pick them pretty close to your axis of symmetry, otherwise they may get too far down and they won't fit on your graph. And then after you plot those, you just reflect them across the axis of symmetry. When you have the standard form, we're going to want the same important information, but it's going to come from different places. So you identify your A, your B, and your C. To find your axis of symmetry, your vertical line x equals, take the opposite of your B value divided by 2 times your A value. To find your vertex here, there's a little more work. What we need to do is take the x value that we get when we calculate the axis of symmetry, that's the x of our point, that is our vertex. To find the y, you go back to the original equation, plug in the x values, and simplify down, and that'll tell you what your y is. Plot your point. The standard form has an additional point already there for us, and that's our y-intercept. It comes from the c in the equation. So we plot that on the y-axis, and the point name is 0, whatever the c value is. So when we make our graph, we put our axis of symmetry, we plot our vertex, we know it opens upward because the a was positive in this case. Well, we didn't have an example, but this would be a positive a because it opens upward. Then we have our point on our y-axis, which comes right from the c value in the equation. We can reflect that point, count how many spaces it takes to get to the axis of symmetry, count the same number of spaces on the other side, and then you can make your curve through that when you find one additional point to help guide you. And that's the side-by-side of vertex form to standard form.